Question number 7 from the EOT. Find limit at infinity and limits that are infinite. So let's start with questions 9 and 10. Now, whenever we have a polynomial over polynomial, and I explained this in previous questions, in previous videos, whenever you have a polynomial over polynomial, all you need to do is compare the degrees. If the degree of the numerator is higher than the degree of the denominator, then the answer is either positive infinity or negative infinity. If the degree of the numerator is equal to the degree of the denominator, then you need to take the ratio of the leading coefficient. If the degree of the denominator is higher than the degree of the numerator, then the answer is directly 0. So when I come to question number 9, I see that the degree up is 2, because 2 is the highest power. So degree up is 2. Degree down is 2. The degrees are equal. So what does this mean if the degrees are equal? Take the ratio of the leading coefficients. How do we take the ratio of the leading coefficient? I go to the x of the highest power. What's the number beside it? 1. What's the number beside this one? 3. So the answer is directly 1 over 3. Now same thing with question number 10. Highest degree up is 2. Highest degree down is 2. They are equal. So I take the ratio of the leading coefficients, which is 2 over 4. That simplifies to 1 over 2. Now, both of these equations can be done using the calculator. How can I find the limit using calculator? All you need to do is write the function same as it is. So here I will just write the function 3x squared plus 4x minus 1. Now I will click calculate. Now where is x going? It's going to positive infinity. So I am going to put a very large positive number. And I will click equal. What did the calculator give me? 1 over 3. That's it. This is the answer. Same thing with question number 10. Here I can go ahead and write the function 2x squared minus x plus 1 over 4x squared minus 3x minus 1. Then again I will click calculate. X is going to positive infinity, so I will put a very large positive number, okay, and I will click equal. What did I get the answer? 1 over 2. Okay, now look at question number 11. If I were to do it with the calculator, so negative x over square root 4 plus x squared. I will click calculate. Now the x is going to negative infinity, so I will put a large negative number. Don't forget the negative. And I will click equal. So the answer came out to be 1. So here's the answer is 1 from the calculator. Now I go to question number 12. How do I do this with the calculator? Again, I am going to write the function same as it is, and then I'm gonna click calculate. Here positive infinity, so a positive large number, so I am just clicking more and more zeros. Okay, so what did I get? 5 times 10 to the power negative 30. Whenever you get times 10 to the power of something that is negative and it is a very large negative, then this means this is 0. Okay, how can I do 11 and 12 by myself? Well, let's do 11. Limit as x approaches negative infinity, and I have explained this also in a previous video. What you do is you go to the part that has a root. You only care about the term that has the highest power. So the term that has the highest power is x squared. So I don't care about the 4. So I will put the square root of x squared. Now the root and the power can cancel each other, but the x will be inside an absolute. So you don't write x, you write absolute x. Then you look at the x. Where is it approaching? It's approaching negative infinity. If the x is approaching negative infinity, you remove absolute x and you put in its place negative x. If this is approaching positive infinity, you remove the absolute x and you put in its place positive x. So now here, since we are approaching negative infinity, I will remove absolute x and I put in its place negative x. Now negative x over negative x is 1. Limit as x approaches negative infinity for 1 is just equal to 1, same as we got in the calculator. Now question number 12, if I compare the degrees, because this is a polynomial over a polynomial, the degree up is 2, the degree down is 3. So if you notice at this case, when the degree of the denominator, the one that is down, is higher than the degree of the numerator, the answer is directly 0. Okay, now we come to the next set of questions. Limit of this. Now for the len, again, I explained this in previous videos. Please go and watch it in more details. What do we know about the len? Well, we know that the len, as x goes to infinity, the len will go to infinity. So you need to know the limit as x approaches infinity for len x is also infinity. Now what about as it approaches 0? As it approaches 0, this is an asymptote. Now 0 from which side? We are only from the right side. We cannot be in the left side. This is how the len is. So the limit as x approaches 0 for len x is negative infinity. So we need to know these properties of the len. Now we start from here. Len x squared plus 1 over x minus 3, limit as x approaches infinity. So now from properties of limit, I can find the limit of this one first, okay, and then find len of this. So what is the limit as x approaches infinity for this thing inside? Well, the degree up is in power 2, the degree down is power 1, so this one will go to infinity. So I will end up with len of infinity. Now what do we know about len as x goes to infinity? Okay, what do we know about this? We know that it will go to positive infinity. So that is the answer. Now how can I show this with my calculator? I will open my calculator and I will write the function len x squared plus 1 over x minus 3. Now I will click calculate and I will put a large number. What do I see? I see 16.118. طيب, I go back and I make the number even larger. What do I see? 32. So first it was 16. Now it became 32. Okay, let me go and make the number even larger. I will make it larger, 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 larger. Keep adding zeros. What did I get? 59.8. Okay, look at the pattern that you get. The numbers keep growing larger and they keep growing larger in the positive direction. So the answer is positive infinity. Now I go here, I find limit as x approaches 0 from the right for this. Okay, len of x sine x. So here you can find the limit of what is inside, 0 from the right for x sine x. So what do we get here? You can directly substitute. Instead of writing this, x is 0, sine 0. Sine 0 is 0, 0 times 0 is 0. So we get what? Ln 0. What do we know about ln 0 from the right? Well, we just said ln 0 from the right is going to go to negative infinity. Again, how could I have done this using my calculator? I will go and I will write the function ln x sine x, close bracket, calculate. Now 0 from the right means 0.0001. Let's see what do we get. First one, we got negative 32. Again, I put calculate and I make the number even closer. Sorry, here there should be no negative because it is 0 from the right. Now what did I get? Negative 55. First it was negative 32. Then it became negative 55. Okay, what if I keep making the number closer to 0? So I will add here zeros. What do I get? Negative 110. Look at the numbers. They are growing more and more. They are becoming bigger and bigger. But in which direction? In the negative direction. So the answer is negative infinity. Now we come to the e, the function e, question 15 and 16. What do we know about the function e? You need to remember this. E is an exponential function. As e grows in the positive infinity direction, the function goes up. So this means the limit as x approaches infinity for e power x is infinity. What happens when we go in the negative direction? The function will approach the 0. So the limit as x approaches negative infinity for e power x is 0. We need to know this about the behavior of the e function. Okay, so limit as x approaches 0 from the right for this. So I will substitute. I will have minus 2 over x power 3. Instead of x power 3, I will put 0 from the right. Okay, and here power 3. Now what does this mean, 0 from the right? Look here with me, please. You need to focus on this one. 0 on the right means it is a positive number. When I cube a positive number, it will remain positive. Okay? Now, there's a negative up. Negative divided by positive is negative. So all of this here will be negative. A number over 0 is either positive infinity or negative infinity. Since I know all of this is negative, so this is like e power negative infinity. What do I know about e power negative infinity? It is 0. So the answer is 0. That's it. Again, my calculator, I will write the function. So here we have, this is the e, power minus 2 over x cube. Shift calculate, 0 from the right, yani 0.000001. Put equal. What do you get the answer? You get the answer to be 0. Again, when you get 1 times 10 to the power a negative large number, this means 0. That's it. Okay, now we come to this one. Limit as x approaches infinity, e to the power minus x plus 1 over x squared plus 2. Okay, again, as before, I can find the limit from properties of limit of this one here that is up, and then find the answer. Now look, the degree up is 1, the degree down is 2. When the degree up is less than down, this answer means 0. So this limit is 0. So I will end up with e power 0. What is e power 0? E power 0 is 1. Or you can put it on your calculator and you will see this. Again, here is my calculator. Shift e power minus x plus 1 close over x square plus 2 shift calculate. Infinity means a very large positive number. I will click equal. Now since the number is very large, the calculator might take some time. Okay, probably the number was way too large, so let me click calculate again. Let's make it a little bit larger. Okay, so now look, 0.998. So this is approximately what? 1. Let me try adding more zeros. Maybe it will not give me error. So 0.99999. So this is almost 1. Let me add more zeros. So here, how many zeros did I put? 1, 2, 3, 4, 5. Let me add. So look, 0.9999999. So this is approximately what? 1. The more you add the zeros, the more accurate it is. So here, now it is exactly 1. Okay, now we come to the next type of questions, which is cotan inverse. Cotan inverse, you need to know the behavior of the cotan. Cotan inverse looks like this. This is how the graph of cotan is. Okay, so the limit as x approaches infinity for cotan inverse, as x keeps growing, the function keeps going to 0. So the limit of cotan inverse x as x approaches infinity is equal to 0. Okay. Here, let me just... Okay. How could I have done this using the calculator? Is cotan inverse the same as 1 over tan inverse? No, this is completely a misinformation. Many people think this, but this is wrong. To use this in the calculator, cotan inverse, because the calculator doesn't have cotan. So how am I going to use this? Cotan inverse is the same as pi over 2 minus tan inverse. You can use this relation. So I can go to my calculator. I can say, because the calculator doesn't have cotan, it only has sine, cosine, tan. I can say pi over 2 minus tan inverse. Now where is x going? Infinity. So I will put here x, then I will click calculate, and then I will put a very large number. So now look, what did I get? 1 times 10 to the power negative 9, which means what? 0. Now in the final, maybe they don't tell me x goes to infinity, they tell me x goes to negative infinity. So also I can use the same relation. I can say calculate negative very large number, and I click equal. So what is the answer? The answer is pi. So as x goes to negative infinity, this is going to what? Pi. Okay, now I go to the secant inverse.